Hello everyone, welcome to my channel. Today we're gonna to continue talk about how to analyze CRISPR high-throughput screen data. So in my last video, I have introduced the experimental approach of normal CRISPR high-throughput screen and how we can use a tool called MAGIC to map the reads to our sgRNA library and count each sgRNAs and get a preliminary result of the hit. We will continue to validate. Okay, today I'm going to talk about another tool which can further analyze the data and compare different conditions and do some network and geo analysis with a single software and a very user-friendly interface. Okay, so this software is called MoPAC. Let me show you. So MoPAC is a software developed by my former colleague, and he developed this method called a modular pipeline for the analysis of CRISPR screens, and it can this is the major features of this software. It can perform unbiased measurement of differential gene essentiality. So it can compare multiple conditions with drug or without drug, treatment, untreatment, different drug comparison, etc. And it has an ease of use through an interactive graphical user interface. So it's not like a command line, and it has a very user-friendly interface. You can just click and do the analysis with interactive graphical interface. Okay, and it can generate publication-ready figures at every step of the analysis, and FASTQ files, read count tables as input, and quality controls and geoanalysis. Okay, these are the files. You should download this latest version, and the installation is very simple. You just open the terminal and run in R or in RStudio console, and use install. Okay, and these are all dependencies you need to install before you can install this. Okay, just install this package first and then use this command. Okay, then I will show you how to use this software. So let's open RStudio. Okay, I have already installed the MoPAC on my computer. So you just follow this instructions and install it by yourself. Okay, if you have encounter any problems, just let me know with command. Just comment and let me know. Okay, let's run it. Okay, you can see this interface. Okay, and you can open it in browser to make it more stably. Okay, so we don't do the FASTQ alignment. We can do the FASTQ alignment with MAGIC, and today I'm going to talk about quality control and analysis with single condition differential analysis and network. Okay, so here we need first to select a working directory. I heard the directory is under the here. Do this. Okay. It's called MoPAC test. Okay. Let's select. Okay, I will show you in the MoPAC test. We have like two files. One is the library. Okay, this is SGI library. Let me open it and show you what it looks like. Okay, there are three columns. One is the first is sGNA, second is gene, and the third is category. So this category means others means all the genes you want to target in your library, and it also has like a positive non-essential non-targeting as a negative control, and the essential gene as positive control. So it is used for quality control. And another one is a count table. Okay, I have shown you in last video, and this count table is from screen in our study published on the nucleic acid research, and it has this sGNA gene and read counts for at each condition. This for plasmid, and this is for DMSO treatment, replicate 1, 2, and 3. And this is PMT5 inhibitor treatment condition 1, 2, and 3. Okay. With this count table and library, and we can go ahead for the analysis. And let's just browse the count table here in the library here. Click run. And there will just show some statistic about the library, how many essential gene, non-essential gene, and others, sGNA level and gene level. How many counts per gene in this library is 10, and how many counts for each condition in total. Okay, count of zeros, so these are unmapped sGNAs. Everything seems okay. And then we need to fill this form by ourselves. It's a little bit time consuming, but it has to be done before you go ahead. So we need to first put plasmid here. Plasmid is a control, so if it's D0, you just click DO, okay. So this is DMSO. Okay, these three are DMSO, so let's see. So this PMT5 inhibitor, then we did PMT5, okay. So this condition needs to be it can be used as a label for this condition, and later we just use as a prefix for all the files, okay. So replicate, you can see R1, okay, R1. So this is also R1. So the plasmid only have one replicate. So this has R2 and R3. So let's replicate it. Okay, this is also R2 and 3. So controls, if the itself is a control, then it leave blank. Okay. So if it either controls, okay, all the other conditions use plasmid as control. So you just plasmid. Okay, click we finish. I finished, right? So we can see the distribution here. Okay, this quality control here means the essential gene should have depletion. Okay, have depletion here, and non-essential and non-targeting should have no effect, and the other genes should be a little bit close to the non-essential because the majority of the genes have no effect, but they still have many genes have effect close to the essential gene. So this is a good screen. And at the sGNA level, we can see more clear. Okay, so essential, very high, very negative log4 change means depletion of the cells, and non-essential and non-targeting. above 0. Okay, so this it's a good quality. The correlation means can see the DMSO conditions are clustered together and the PM25 conditions are clustered together, so that's reasonable. And then reproducibility measures the reproducibility among different replicates under certain conditions. So for DMSO, the R1, R2, and R3 are highly correlated. That means the reproducibility is good. So let's see PM25 condition. It also pretty good. Okay. So this table is just the log fold change comparing the DMSO to the plasmid controls. So this table will also saved under your working directory. And so next we will go to the single condition analysis. So we just run. So this will output the volcano plot for the DMSO compared to the plasmid control. And this is a log fold change, and this is the p-value. And we can see we can highlight some genes. So this gene, right? No, you can select some regions as this plot. It will show up as this window, and you can click any genes you like here. You want to highlight some genes, like for example, AP5. Okay, it's here. Okay, it also has some tables. So this table is for DMSO compared to the plasmid control. Okay, so these are the this is the log fold change. If it's positive, that means positive selection. So it's enriched, number 1. Number 2, it's ranked by the FDR. And you can also see the PM25. Okay, you can plot. And you just select, okay, it's PM25. Okay, it changes to PM25. It's the same. So this is a table for PRMT5. These tables were also generated under your working directory. And next is the differential analysis. So you can see whether it's compared to conditions like DMSO condition and PM25. You want to see whether inhibit PM25 will cause knock out some gene will cause the cell more sensitive to PM25. Then we select PM25. Okay, it's more sensitive, and DMSO is less sensitive. So that's a comparison. Okay, that's wrong. Okay, so this is PM25 compared to DMSO condition. That's a differential essential reality analysis. Let's see what's going on here. This is PPP4C, and in our study, we found this gene PMT1 will sensitize the cell to PMT5 inhibitor. That means PMT1 and PMT5 have synergistic effect. So these are key findings. Later experiment validation is around these findings in the screen. Okay, so this is this highlight PMT5 itself and PMT1. Okay, so PMT1 is PMT5. Because PMT5 is reasonable, because if you knock out PMT5 and inhibit again, then it will cause the cell cause more die of the cell. Okay, says John PMT5. So it's John we want to see whether different SGA cause similar effect. usually different multiple sgRNAs will give more confidence if they perform consistently. So you can see majority of the sgRNAs are how the effect. That means it has an effect on PMT5, but has no minor effect on with DMSO. Okay. Finally, it's a table. Okay. So this table means if it's more rank higher, that means it cause more sensitive to PMT5. Okay. Let's see that this score is minus CFDR. And this table is also generated on the working directory, and you can look it up and plot the figures you want. So like this figure. These figures are also can be used. Okay, you can download the figure. Okay, the last step, you want to do some network analysis and pathway analysis, etc. You can run. Okay, this is the network of the top hits, PMT1, PMT5, these genes, and let's see pathways. These are KEGG pathway and find pathway. Okay, the most enriched one is spliceosome and RNA transpose, etc. How about process, biological process? Okay, we can find RNA splicing and mRNA splicing, etc. So this is reasonable because PMT5 is highly related to RNA splicing process. Function, what function? Can see histone methyltransferase. Okay, PMT1 and PMT5 are both methyltransferase. P-farm. Okay, so you can just play with your own data on this well-designed interface called MoPAC, software called MoPAC. So if you encounter any problems, don't hesitate to let me know, and I'm here to help you. Okay. All right. So you will find all the learning materials in this channel, and the link to the softwares in the description under this video. And if you like what you see, don't forget to like the video and smash the subscribe, and stay tuned for my updates of coming videos. And okay, I will see you next time. Bye bye.